So in the last video we saw what polyatomic ions were. They're basically charged molecules, and how to write formulas from them, and how to name ionic compounds that contain them. But there are many other polyatomic ions, and most of them contain oxygen. They are called collectively oxyanions. The oxy tells you there's oxygen in there, and the anion tells you that they are negatively charged. An anion, remember, is a negatively charged ion. A cation has a positive charge. The most common oxyanions have an ATE ending. And there are some of these that you are just going to need to memorize because they crop up so often. For example, this is nitrate. It is the most common oxygen-containing ion of nitrogen. So you combine nitrogen with oxygen and you make an ion out of it. This is the most common combo of nitrogen and oxygen as an anion. And how do I know it's 3? Why not 2? How do I know the charge is -1? Why not -2? Well, we can answer questions like that, but only after we learn how to draw Lewis structures. So for now, and in general, we want to memorize this. So make yourself a set of flashcards, put this on a card, and on the other side write nitrate, and drill yourself on these so that you get quick with naming them, because you will see them all the time in medicine, in environmental science, chemical analysis, a lot of different places. News stories will mention these ions. It's basic chemical vocabulary that you need to learn. So nitrate is one of them. What are some others? These are all listed, the ones you should memorize, on the second page of the tips sheet that I have posted under this lesson on the website. This is chlorate. And you can look underneath chlorine on the periodic table. You've got bromine. And its most common form is analogous to that. Notice you just swapped the bromine for the chlorine. These are both in the same family. So they're going to form very similar polyatomic ions. And below that, on the periodic table, is iodine. And that forms iodate. All of these have that ATE ending. Some other polyatomic ions. That's cyanate. Now, you know cyanide from the last video. This is cyanate. Permanganate. Now, per in front, we said in the last video, is a prefix that means stuff an extra oxygen in. And you could kind of guess that manganate would be MnO3-. But it's not common. This is a more common ion, and this is one that we actually use a lot. Okay, one more -1 ion. All of these are -1 ions that I have here. This can be written this way, or the way your book writes it, and the way organic chemists write it. Either of these forms is called acetate. Now, people will sometimes write it down like that to show how it's wired up. The molecules hook together something like this. And when they write it out like that, they're trying to show you how the atoms are arranged. This is something organic chemists do. In inorganic and general chemistry, you'll mostly see it written down like this. But this and this are the same thing. They're both acetate. Okay? So those are the -1 ions to know. How about -2 ions? There's carbonate sulfate. Now, notice that this one has a 4 down there and this one has a 3. You're just going to have to memorize that for now. Oxalate. Okay, and there's this weird one, which is kind of important in oxidation reduction reactions. It's dichromate, they call this. It's a common oxidizing agent that you use in a lot of analytical chemistry. So it is something you'll see again. So these are the -2 ions that we have here. Okay, let's look at some -3 ions, and there aren't many of these. In fact, there's only one really that you need to know. Only one -3 ion. And I guess I can write it down on the bottom here. I can squeeze it in. That's phosphate. Extremely important biologically. PO4 -3. So if you memorize this list, you're going to know most of the oxyanions that you need to know. In the next video, I'll show you how to write down other ions from the formulas of these. Now let's play with them a little bit. Let's suppose that I give you the name of a compound. And I ask you, what's the formula? How do you do that? Well, you know from the last video that ammonium, excuse me, is NH4 plus. And you know from what we just went over that chlorate is ClO3 minus. So you're going to need to have that tips sheet with this table in front of you for a little while until you learn them. And you write down the formulas. So when you look at a name, there are, if it's an ionic compound, there are 2 names. You're going to write down the ions that go with each of those. And then you're going to put them together so that their charges balance. All right, this is a +1, and this is a -1. So you can put it together just like this. I don't need to put any parentheses in there because you only use parentheses when you have multiple copies of a polyatomic ion there. If I had, let's do another one. Aluminum sulfate, which is used in a lot of different applications that involve water purification. So if I have aluminum sulfate, I am going to try to write down the formula for this. I'm going to write down the formulas for the ions. How did I know that it was +3? I need a periodic table, and I need to look at the charges on the most common ions in the column. So if I look where aluminum is, it's in the +3 column. All right, everything in this column will form +3 ions. And then sulfate, I'm going to do it wrong. What's wrong with that? That's sulfide with an IDE ending. So that's not right. And it's got an ATE ending, so I know that there has to be some oxygen in there. And if I look at my polyatomic ion table, it's there. Now, how do I put these together? I can't put just like I did with the last one. I can't just throw these together because that won't work, because I have a +3 charge and a -2 charge here, and they don't balance off. Now I can get them to balance if I have 3, well, here, let's do it like this. So they don't balance off. I don't have enough negative charge to balance that off, so I can try adding another one. Alright, now I have too much negative charge. I have a -4 and only a +3. So how about if I tip it back this way and try and add another one of these? Now I've got +6 and -4. So maybe I'll add another one of these. And I can keep seesawing back and forth until I see a balance there. There's a +6 here and a -6 here, so now they're balanced. So I can write, what? Al2 SO4 3. See, that will be the formula for this. I have to use parentheses because I have 3 copies of that. Now I don't have to use parentheses around the aluminum because it's a monatomic ion. You only use parentheses when you have multiple copies of a polyatomic ion. Alright, there's a quicker and easier way to do that, and we talked about this in an earlier video when we were doing just elemental ions. You can swap the charges as subscripts. So if I see a 3 here, I can put it as a subscript on the sulfate, and if I see a 2 here, I can put it as a subscript on the aluminum, and I can get just very quickly Al2 SO4 3, and that would be aluminum sulfate. Okay. Now I can go the other way too. I can take these formulas and I can derive names for them. Let's look at this one. Here's a formula. And I want to figure out what the name on this is going to be. This compound is using Scandinavian cooking in baked goods. It gives them this sort of characteristic biting flavor, sharp flavor. Anyway, I want to name this compound. The common name of it is hartshorn, by the way. But what I'm going to have to do is the reverse of the process we were doing before. I am going to have to look at the ions that are inside here. There are 2 of these NH4 plus ions. The only way I would recognize them as NH4 plus is if I knew my polyatomic ion table. You can always tell when people don't know their table because they will do something like this. Oh, well, there's a nitride in there, and there are 4 H pluses in there. So they'll break it all the way down like that. Now, this is a common ion, NH4, and if you know your ion table, you can recognize it in there as sort of like as a word instead of recognizing the individual letters. Alright, so you know it's an NH4 plus, which is called an ammonium ion. So the name of this compound is ammonium something. And now we can name this one CO3. Somebody who didn't know their polyatomic ion table would say, oh, well, there's a C-4 in there and an O-2, 3 O-2s. Or they might say there's a C-4 in there and there's a O3 plus 4 or something. You know, they might do something crazy like that. But if you know your polyatomic ion table, you recognize that as one of the ions that you should know. It's a carbonate ion in there. Now, these ion charges make sense too, because there's a +1 on the ammonium and there's a -2 on the carbonate, so there should be 2 ammoniums for every carbonate to balance it off. So what you do is you pick out what kind of ion you have there in each case, name that ion, push the names together, and that gives you the name of the compound. That is the best way to practice, to learn this table that you have here. put a big box around this. This is something that you're expected to memorize. And practice it by pushing together these ions with different things and checking the names. You can always Google the name and of the compound, and you can check your answers that way. And there's a lot of these in the book too.